Alright guys, welcome to your video lecture today. We're going to be learning about the carbon cycle. So far in our unit we've talked a lot about climate change, or not climate change, about our climate, like how it normally is, how it's normally meant to function. We've gone into air pollutants a little bit. We talked about acid rain and we talked about ozone. And now we're going to talk about the carbon cycle, which is going to be vital in understanding the greenhouse gases and greenhouse gas effect, and then later climate change in general. So today is dedicated all to the carbon cycle. So you're watching this, that means you found the video lecture link right here. And then I'd also like you to watch the NOAA video on what the carbon cycle is, because it kind of quickly and succinctly goes through everything we're going to learn today, and it's going to be a good checker that you've understood the carbon cycle. So if you're in person, you've got this in your notebooks. If not, you've got an editable copy right there of your PDF. But without further ado, here is, or however you say it, here's the carbon cycle. So we're going to start with the left side of our page and go through what pretty much you should see or recognize as a food web or a food chain. So remember, our food chains start with a producer. And producers are the green things like the plants, algae, and in our water ecosystems, especially up where the waters are colder, we have phytoplankton too. So any organism that does photosynthesis, remember, photosynthesis takes carbon dioxide from the atmosphere and uses energy from the sun to create macromolecules or carbohydrates, which give the plant energy. Now, we know that as we go down the food cycle, that something's eventually going to eat that plant, most likely. We call whatever eats that a consumer. So this could be people, animals, insects, anything that's not green and doesn't photosynthesize. So if you remember from 8th grade, producers are also called autotrophs because they make their own food. Consumers are considered heterotrophs because they need to eat something in order to get the nutrients they need. That's a consumer. So what we're doing here is we're tracing the carbon from one organism to the next, or from one thing to the next. So our carbon started over here, which we'll write down at the very end, which is carbon dioxide from the atmosphere. So that's brought into the plant or algae or phytoplankton, and they use that to build their carbohydrates or their fuels themselves. Remember, they make glucose, C6H12O6. Is our chemical equation for glucose, if you don't remember. We'll talk about that in biology next year though. But so they take that carbon from the atmosphere and they make sugar and glucose so that they can do their regular cellular processes so they can grow and live. And then other things eat that so that they can grow and live. So maybe I eat a salad for lunch. I'm taking the carbon that was in the plant in the form of glucose and I'm putting it in my own body so I can make my own glucose and I can make my own energy from it. So we're tracing the carbon. So the carbon's in the glucose now from the producer to the consumer. So how is carbon passed from one organism to another here? It's simple. They're in this relationship right here, this arrow, it's an eating thing. So the consumer is eating the producer, which has the carbon. And remember, all things respire, they breathe. So what is the waste product of cellular respiration? It's carbon dioxide. So the carbon dioxide, when the people, animals, insects, or plants, or algae, or phytoplankton breathe out, they're breathing out carbon dioxide. So that carbon dioxide is returned to the atmosphere so it can be used again by a producer. This should all be ringing a bell. You should have learned about this before. And again, we're going to talk about cellular respiration and photosynthesis a lot in biology. So maybe you don't know the exact, like the Krebs cycle and the exact processes, but you should understand and you'll need to know that when things breathe out, they're breathing out carbon dioxide. So our consumers here are breathing out carbon dioxide, our plants are breathing out carbon dioxide. And now for our next slide, and you will type these down and these down. For our next slide, what happens when things die? What happens when our consumers die or our producers die? They're decomposed, right? And our decomposers are fungus. So funguses are mushrooms, mold, and yeast. So they decompose things. And then our bacteria, which also decompose things. And then our worms, our annelids, or there's another word, starts with an H, but I can't remember it. but worms is what you need to know. So those things are going to decompose the dead organic matter, whether that be plant or animal, and that's now the carbon is inside those decomposers because, again, they've eaten it. Don't forget here that decomposers also respire, so they also breathe out. As these organisms decompose, though, some of the carbon is returned back into the soil, especially our bacteria and fungus. They use a little bit of the carbon for themselves, but they will return a lot of it back into the soil or environment. So that's where our next arrows go. Remember, the decomposers breathe out. Anything living breathes out, and when you breathe out, if they're doing cellular respiration, which all are, it is carbon dioxide. So when we go from the decomposers to the carbon sinks here, it's the decomposer returning the carbon to these different things. And carbon sink, again, a confusing name, but we'll get it. So is this a carbon sink right here, the sink? No. A carbon sink is actually anything that stores carbon, and it's generally for a long period of time. So carbon sinks happen when dead organic matter, because after it's been decomposed by our decomposers, bacteria, fungus, or worms, they return that carbon to the soil, and it kind of sits there. So some of that carbon can be stored in the soil. Some of it can be stored in rocks if that soil mineralizes. Again, some of it could be turned into fossils if any of our dead organic matter forms a fossil. Some of it is stored in the ocean if things are being broken down in the ocean environment. And then some of it is taken up by the plant in through the roots as well. So our trees are often considered major carbon sinks. Again, a carbon sink is anything that stores carbon. Now, all of what we've talked about right now is a very natural process. Humans don't really have any, except we do eat, and we are part of this. We didn't mess this part up. All of this is natural. So if this were left alone and this was the end of the story, we wouldn't be talking about greenhouse gases or climate change or the greenhouse effect. But the problem is that over a time, or much later, after the carbon has sat in the soil, the rocks, the fossils, the old trees, they form fuels. So they form the coal, the oil, the natural gas, and the peat that we use to power whatever it is, power our houses, power the schools, power our houses, heat our houses, power our agriculture, farming vehicles. So we've taken what has sat in a carbon sink for millions and millions of years, and that carbon sink is not causing any issue. It's not changing the environment in any way. That was all natural, but we have taken these, so our coal, our oil, our natural gas, and our peat, and we decided that we want to burn them, which is our next slide, which we'll talk about. So I just wanted to clear some things up with you. We talk about fuel a lot, but I want to show you kind of how it was formed. So our dead organic matter decays, and it decays between two rock layers that are really confined, meaning that not much goes and or can pass between this and this. So these are like barriers. And then as they decay, they can form oil. And above the oil, we typically get a natural gas section. So it not only forms oil, but it forms natural gas. And that's where we get our fossil fuels from. Peat we'll talk about in just a second, but this is underground coal and oil. And coal forms underground as well, except the oil becomes rock, so it turns into a solid. Or the dead organic matter becomes rock. But we use this oil to, what is it called? There's a fancy word for it, but I can't remember what it is. But we change the oil, for the crude oil, and we turn it into like the gasoline that we need, or the diesel fuel that we need, or the airplane fuel that we need. We modify it, and we do some kind of chemical reaction to make it the oil that we need. But that's where we get it from. And so that's been there for millions and millions of years. Remember, we talked about much later. So those carbon sinks, it's fine under the ground. It's not doing any damage. It's just being stored there, which is absolutely natural and normal. But the problem is humans have come in and we've taken these old sinks of carbon and we've used them for our own good. And what we do with them, I hope you know, is that we combust them, we burn them. And when we do that, they release carbon dioxide into the atmosphere. And again, some carbon dioxide is naturally released into the atmosphere. If my little picture of wood here is to remind me that another of our carbon sinks is also wood. So forests are generally thought of as big carbon sinks as well because they store a lot of carbon inside the fibers. But as we burn our wood as well, it releases carbon dioxide into the atmosphere. The problem is that we are combusting or burning these fuels, and as we burn them, they break down into their carbon, which releases carbon dioxide into the atmosphere. Now, again, the carbon cycle is natural. This all would happen naturally whether humans were here or not. But the problem is that we are using this fuel and the combustion at an unsustainable rate. So we're using too much of it too fast. And we're actually we're offsetting the balance. The earth and the environment is all about balance, so a give and a take. But we are taking and using and releasing more than can naturally be filtered through the cycle. So we're producing way more carbon dioxide in the atmosphere than the plants can take in and need. So that's why we have an unbalance. And that's why we're experiencing some of our global warming and our greenhouse effect, because we are releasing too much carbon into the atmosphere. So I wish I would have found a chart. Maybe I'll find it for our next lecture. But this part is happening way more than it would naturally if humans weren't here. And that's why we're getting into trouble. So when we talk about climate change and when we talk about greenhouse gases, we're also going to talk about, okay, like this is happening and it's bad, but we're going to talk about how we can, as young citizens, change what our past ancestors have done and try to focus on more environmentally friendly and environmentally conscious forms of either fuel or energy. So how are you going to stop this? So it's really exciting to be learning this and thinking more about how you're going to be better than the generation before you. But that got way further than it should have because we're just talking about the carbon cycle. But again, this is a natural cycle. The problem is that humans are using too much of it. We're focusing too much on the fuels and the combustions, and we're releasing carbon dioxide, too much of it, so it can't naturally cycle through the cycle. So we are throwing the cycle out of whack. That is the last bit of notes. So once you finish your notes, if you will turn them in, that would be fantastic. Tomorrow we're going to look into the greenhouse gases and talk about why the carbon cycle matters and why what we're doing with our carbon dioxide and other greenhouse gases matters and how it's affecting our climate. Remember, watch that video as well. It's only about 3 minutes, so it won't take you very long, but it'll show you really nicely a quick version of the carbon cycle and why we care. All right, guys, enjoy. Have a great day.